Hey, thanks for joining me as we talk about probability distributions from lesson 1.03. We'll probably mix in a little bit of information from 1.02 as well. We're going to create probability distributions, interpret probability distributions, and interpret data in different forms. So it's all about probability distributions, and the thing we're going to have to kind of add in here is just what is probability. So we're going to skip this one because nobody watching this with us. So we're going to create a probability distribution. This is how it works. I'm giving you a bunch of data here. 104 people in class have brown hair, 72 people have green hair, 150 have black hair, and 13 have orange hair. And when I say the word probability distribution, probability, what I'm asking is, what are the chances, what's the probability that if I pick a person at random in the class, they would have brown hair, let's say. So that's the probability of picking a random person at random in the class, and they're having brown hair. That's the probability that we're looking for, and then we'll also do that for green hair and black hair and orange hair. Okay, so how do we find those probabilities? Well, let's take a step back and remember what probability is. Probability is simply what we want to happen divided by what could happen. Okay, if you remember that, want divided by could, you'll always be able to get this figured out. So what we want, if we want to find the probability, what's the probability of brown hair? Then what we want to happen is we want to pick somebody with brown hair. There's 104 people to choose from with brown hair. And what could happen is you could pick anyone in the whole class. So how many people were in the whole class? Well, in order to get that, we have to add up all the people. There's 104 with brown hair, 72 with green, 150 with black, and 13 with orange. So we add those all up and we get 9 and 13 and 339. I think that's right. Check my math. 339. Now I have to pull out my calculator to get my probability here, because probability is it's a fraction or a division problem, right? 104 over 339 could be written on our calculator as 104 divided by 339. And when I do that on my calculator, I get approximately, and I'm going to say approximately because I'm going to round, 0.30, I'm going to say round it to 7. So round it to 3 decimal places. So 0.307 is 30.7%. So I could have rounded it to 31%. I could have said 30.68%. I could have rounded off to 4 decimal places, 5, and so forth. So I think this is probably the best. So there's my probability. I'm going to keep it in decimal form for my probability distribution chart. And so let's start working on a chart here. We'll put our chart, and we'll have X. X is the data that we're counting, and then we'll have P. P is the probability. So the data we're counting first is brown, and the probability is 0.307. And then we're also going to calculate green and black and orange. All right, and that's all you do. That's all we do. We'll go ahead and run through the numbers really quickly. Green. So probability of green would be 72 people with green hair out of 339. Again, pull out our trusty calculator. If you don't know where your calculator is located on your computer, you have one. Even if you have a Mac, you've got a calculator on your computer. Definitely come by and see me and ask for help on there. That's going to be approximately 0.212. Then we'll do the probability of black, and that's 150 out of 339. Now notice 150 is half of 300, so it's going to be almost 50%, a little bit less. And indeed it is at 0.442, so 44%. And then the probability of orange is a really small number, 13 out of 339. So that's going to be a very small percent. 13 divided by 339. Almost no one in the class has orange hair. 0.038 or 3.8%. And so that's all there is to that. I don't know why more people don't have orange hair. When you're doing a probability distribution, you can always check to see if it's right. You can't be guaranteed that it's right, but you can check it by taking the total, by adding them all up. So I'm going to do that here. I'm going to add these together. So 8 plus 2 plus 2 plus 7 is 19. Carry the 1, plus 3 plus 4 plus 1 is 9. And then 4 plus 2 plus 3 is also 9. Bring down the decimal point. So notice that my probability distribution does not add up to 1 or 100% as I was hoping, but it adds up to really close to 1. It's 0.999. So if we rounded that, it would be 1. And that's the sign that your probability distribution is correct if the probabilities all add up to 100%, because these are all the different options and the chances of each one, the probabilities for each one, and the probabilities of picking one of these options has to be 100% because those are the only options. All right, that's creating a probability distribution. Let's go to the next page and see what we find there. On the next page, we have that chart, the probability distribution chart that I had on the previous page is written as a histogram. Oh, that's not true. So sorry. This is actually a data table, so this is not, the data table does not show probabilities. Instead, this is, and I apologize, I got mixed up there. This is actually like the data from the last question where it was in the question. So before I said the number of people who had brown hair and that was a big number. Well, here we can imagine that this is talking about red hair and yellow hair and green hair and blue hair and gray hair. And the numbers for each are 3. So there's 3 red, 3 yellow, and so on and so forth. So what's the probabilities for each of these? Well, the probability of red would be 3, there's 3 reds, out of the total, and there's a total of 3 plus 3 plus 3 plus 3 plus 3. There's 5 different choices, so it's a total of 15, 3 out of 15. And when we do that on the calculator, 3 out of 15 is 0.2, which is 20%. Now, does that make sense that the probability of choosing a red is 20% if there's the same amount for each one and there's 5 different choices, 5 different options. Each one has the same probability. It's going to be 20% because 20% times 5, 20% 5 times is 100%. So the probability for each of these is going to be 20% because there's the same amount of each, and 20% is 1/5 of 100%. Now, I showed you this one. This one's actually one of my trick questions from the quiz. The answer that everyone has been picking is this answer where it has 0.3. This is the probability chart. We have the colors for x, the x values on the left-hand column, and then we're supposed to have the probabilities in the right-hand column, but instead everybody's picking the one with the 3 in it, even though it's technically not 3, it's 0.3, it's 3/10, because they're fooled by looking at this chart and seeing the 3's all the way across. But recognize the 3's in the chart is how many of each there are. The probabilities on the probability chart is supposed to be the probabilities of choosing each one, and we just said those probabilities are 20% or 0.2. So since the probabilities are all the same, they're each 20%, we're looking for the chart that says 0.2 for each of the different variables. Okay, you can see how that's kind of a trick question. And what it's trying to do is it's trying to get people who are being kind of lazy, not really thinking about what things mean, just kind of looking for the same numbers. Oh, that number that I see on the graph shows up on the answer, that must be it. You have to think a little bit more deeply than that on these. Okay, question, slide number 6, true probability distributions. Okay, in this slide we want to just go through a little exercise to talk about, to kind of reinforce a couple of things that are true about probability distributions. Probability distributions always add up to 100%, which in decimal form is 1. So 100% or 1. I've made up a probability distribution here. I'm giving it to you in words, and we can write it in a chart if we want to. The probability of picking red is 1 out of 3. The probability of picking blue is 1 out of 4. The probability of picking orange is 1 out of 6. And the probability of picking green, well, I didn't tell you what that is. So that one we're going to have to fill in. So I can write that as a chart. We've seen that before. And we would say X and P over here. So how do we know what the probability of picking green is? Well, remember, the thing we do know about probability distributions is they always add up to 1. So all of these fractions here have to add up to 1 along with the probability of green. So I'm going to do this math problem. The 4 probabilities, 1/3, 1/4, 1/6, and then the probability of green have to add up to 100% or 1. Okay, so they add up together, they add up to 1. I don't know what the probability of green is, but this is an equation I can solve. I think it would be easier to think about this if I didn't have probability of green there, so I'm going to put an X instead to stand for the probability of green, and we're going to solve for X. Okay, so 1/3 plus 1/4 plus 1/6. Now, before you get freaked out about this, just let me tell you right now, you're not going to be asked to do any math with fractions on this particular quiz. So you're going to see fractions because probabilities can be written as fractions, but you're not going to have to add fractions like I'm about to. Okay, but this is a good reminder. Remember, to add fractions, you have to get the denominators the same. The common denominator is going to be a 12, because I can turn each of these into a 12 by multiplying by something. 3 I can multiply by 4, and so that's 4/12. And the 4 I can multiply by 3, top and bottom, that's 3/12. And the 6 I can multiply by 2, top and bottom, that's 2/12. Oops, 2/12. I can't talk and write at the same time. So 4/12 plus 3/12 plus 2/12, 4 plus 3 plus 2 is 9/12. Plus the one probability I don't know, x, equals 1. So 9/12 plus x equals 1. I think you can see that it's going to end up being 3/12, but we can go through the motions here. We can subtract, we can subtract 9/12 from 1, so x equals whatever 1 minus 9/12 is. 1 is 12/12. 12/12 minus 9/12 equals 3/12. 3/12, which is the same as 1/4. We already know that from up here. 1/4 is equal to 3/12. So the probability of green is 1/4. And I want to point out a couple of things. Number one, all the probabilities in a probability distribution have to add up to 1. If they don't, it's not real probability distribution. And notice in this example, the probabilities were fractions. That's good. And the denominators of our fractions were not all the same. And that's fine as long as all my probabilities add up to 1, and we should be good to go. Okay, that brings me to the next trick question, the last trick question. Question number 2. What is wrong with this probability distribution? And so you're going to get this question, what's wrong with this probability distribution? And we're looking at this, and there's all sorts of things wrong with it. And there's all sorts of things that are confusing about it that may not be wrong, but just are confusing. So let me just point out, the most obvious is that the entire thing is fractions. This whole deal is fractions, and that just makes our brains want to explode. So remember that there's 2 columns in a probability distribution. The first column is our data. It's what we are counting, and that can be anything. Remember, the first example we had was the brown hair and green hair and black hair and orange hair. This could have been anything. So could it be fractions that we're counting? Yes, we could be counting 1/6 and 1/5 and 1/4 and 1/3. How many of each do we have? What's the probability of choosing one of those? That's certainly legitimate, but it kind of confuses us or freaks us out when we see all these fractions. So just imagine that they just said brown, orange, green, and black, and then you won't be confused by that. So the results column is doesn't really matter in terms of a probability distribution. The key data is over here. These need to be probabilities, and they are. They're all fractions. So what's wrong with this probability distribution? The first thing it says is the results are all less than 0. The results are just what we counted, and it doesn't matter what they are. So there's nothing wrong with that. Second possible thing wrong, the probabilities have different denominators. Notice that we have a 1/4, a 1/3, 3/4, 4/3. So we have some thirds and we have some fourths. Is that a problem? Well, remember on the last page we had 3 different denominators, and that wasn't a problem at all. So no, having different denominators in your probabilities is not a problem. Okay, the probability in this one is kind of messed up. I should have fixed this earlier. The probability 4/3 is less than 1, or is greater than 1. And that is a problem. That the probabilities, remember, have to add up to 1. So if one of them is greater than 1, then they sure don't add up to 1. So you can't have a probability of something happening that's greater than 1. We joke about in sports they tell you to give 110%, and of course you can't give 110% because you don't have 110%. All you have is 100% of whatever it is they're asking you to give. So you can't give 4/3 of something, of whatever, you can't have a 4/3 probability of something happening. That's 133% chance that you're going to pick this number, and you can't have more than 100% chance of anything. So that's one problem. And then the last problem, the last statement, the sum of the probabilities is 8/3, and that is true. The sum of these probabilities as given here is 8/3 if you were to add all these up, and I'm not going to expect you to do that. You don't have to add them up. But remember that when you do add up the probabilities in a probability distribution, they have to add up to 1. So since one of them is already over 1, they definitely are going to add up to something that's more than 1, and that's a problem. You can't have a probability distribution where the probabilities add up to more than 1. They have to add up to exactly 1 or 100%. So these are the two things that are wrong with this particular probability distribution, and that's the kind of question that you might be asked on your quiz. Okay, that's all I have for you. Thank you very much for watching. I hope this has been helpful discussion about probability distributions. Make sure you do a couple of practice problems before you take your quiz. Have a good day.